Customers reporting payment failures but no alert fired. All dashboards green. The team assumed Prometheus would auto-discover new container IPs, but it was configured with static targets that broke after a Docker restart. Here's exactly why. But first, let's understand how Prometheus and Grafana work together. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Prometheus Grafana setup. Prometheus is an open-source monitoring system that scrapes metrics from configured targets at regular intervals. Grafana is the visualization layer that queries Prometheus to build dashboards and alerts. Together, they give you a complete observability pipeline. The key architectural decision is that Prometheus pulls from targets, not the other way around. This makes it resilient to network partitions and gives you control over scrape cadence. Here's a minimal Docker compose file that runs Prometheus, Grafana, and a Node.js app. Notice we reference services by Docker compose service name. The embedded DNS resolver resolves them. This compose file sets up 3 services. Prometheus and Grafana use official images. The app service builds from a local Docker file and exposes metrics on port 3001. The Prometheus Config file defines scrape targets. Here we use static configs with the Docker compose service name. This works until the container restarts and gets a new IP. This config scrapes the Node.js app every 15 seconds. The target, app 3001, resolves via Docker's internal DNS, but if the app container restarts, the IP might change. In production, services restart and change IPs. Service discovery dynamically generates targets from your infrastructure catalog. Prometheus supports console, Kubernetes, and Docker service discovery. This Docker SD config discovers running containers and scrapes those with the label Prometheus IO scrape. True. The relabel configs extract the container name and map it to a target label. Your app must expose a metrics endpoint that Prometheus can scrape. For Node.js, the Prom client library provides the open metrics format. Let's create a simple Express app that tracks request count and latency. This code registers default metrics and a custom histogram for request duration. The middleware measures latency for each request and records it with method, root, and status labels. PromQL is the query language that turns stored metrics into insights. Rate gives you requests per second from a counter. Histogram quantile calculates percentiles from histogram data. These queries give you request rate, 95th percentile latency, and error ratio. Notice the by clause in histogram quantile. Without it, you get one value for your entire app. Prometheus alerting works in 2 parts: alerting rules in Prometheus and alert routing by Alert Manager. Rules are defined in a YAML file and evaluated at the scrape interval. This rule fires if error rate exceeds 5% for 2 minutes. The for clause prevents flapping. The instance down alert triggers when a target is unreachable, exactly what we needed in the incident. This is the same issue we highlighted at the start. Here's exactly why that happened. The team configured static IP targets in Prometheus. After a Docker restart, the container got a new IP. Prometheus kept trying the old IP, showing the target as down, but no alert was configured on the up metric. The fix was to replace static targets with Docker service discovery. Now Prometheus dynamically discovers containers after restart. We also added an alert on the up metric to catch any future scrape loss immediately. This is the exact mistake from the incident. Hardcoding container IPs breaks after restart. Always use service discovery or Docker compose service names. Depends on only waits for the container to start, not for the service inside to be ready. Prometheus may scrape before the app is listening, causing down targets. Add a health check and use condition, service healthy. Giving Prometheus access to the Docker socket is a security risk. Use a dedicated Docker API proxy with read-only access, or switch to file-based discovery if your orchestrator doesn't change often. A label with 1,000 unique values creates 1,000 series per metric. Times 100 metrics gives 100,000 series. This collapses the server. Never put unbounded labels like userid or requested on metrics. The article mentions that static IPs cause targets to go down silently. Add an alerting rule on the up metric to detect when a target becomes unreachable, ensuring you are notified immediately. The Docker SD configs shown in the article requires Prometheus v2.17.0 or later. Earlier versions do not support Docker service discovery. Verify your Prometheus version before using this feature. The article mentions the black box exporter in passing. Here is a concrete example of configuring Prometheus to scrape the black box exporter to monitor an external HTTP API that does not expose metrics. When things go dark, start by checking the Prometheus API for target status. Then verify connectivity from inside the Prometheus container. Use PromTool to analyze cardinality if queries are slow. Let's run through some common interview questions. How does Prometheus handle target discovery in Docker? Uses Docker SD configs to query Docker API and dynamically resolve targets. How to monitor an external HTTP API without Prometheus metrics. Use Blackbox Exporter to probe endpoints and expose probe success metrics. What is the purpose of relabel configs? Transform and filter discovered targets before scraping, e.g., extract container name. And a few frequently asked questions. Why did my Prometheus target go down after container restart? Static IP changed. Use service discovery. How to dynamically discover Docker containers? Use Docker SD configs with relabel configs. What's the difference between static configs and service discovery? Static hardcodes targets, SD dynamically generates them. To summarize, static IPs cause silent outages. Use service discovery to dynamically resolve targets. Always alert on the up metric. And be careful with label cardinality to keep Prometheus healthy. Ready to go deeper? Up next, Elk Stack, then application performance monitoring, then distributed tracing with Jaeger. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.